Hi everyone, it's Mrs. Kibler. Today we're going to talk about writing piecewise functions when we're given a sketch of a graph. So we are still in our Unit 5 packet. We are on page 25. This is the top of the page, number 6. So we're going to look at this graph right here. The first thing we have to do is we have to notice where the changes in the graph occur. So clearly right here, is where there's going to be a change in the graph. And this is where x is equal to 3. Let's look at our first piece right here. I am going to highlight this in pink. Okay, we are going to need to use our knowledge of the Nifty 9 graphs to figure out which graph this is. If you remember, this is the graph y is equal to 2 to the x power. So y is equal to 2 to the x power. And now we're going to need to figure out what our restrictions on our domain are. Well, we have an arrow, so we know that this is going to go on forever in the negative infinity direction. But once we get to 3, this piece stops. So this is going to be where x is less than or equal to 3. Now let's switch gears and look at our next piece. So our next piece will pick up right here at 3. It will go on and on in the positive infinity direction. This is a straight line, so you're probably remembering Hoy here. When we have a straight line, our equation for that line is y equals, and sometimes we just need to think like the function has no constraints to figure out the equation of that piece itself. So 1, 2, 3, 4. This is 8 right here at 8. Of course, it does stop, but sometimes it helps us to figure out what that is. So let me erase that. So this is y is equal to 8, and this is when x is greater than 3. We'll go on and on forever. So now we can put this together and we can write our piecewise function. So we're going to start with f of x is equal to, we have two pieces here, so we're going to open our brackets. We first have 2 to the x power when x is less than or equal to 3. And then we have 8, f of x equals 8, when x is greater than 3. And there you have it. That's how we write our piecewise function. So let's look at number 7. Now this was a continuous function because it didn't stop. Now we have a non-continuous function right here with number 7. We're going to do the same thing. We're going to look at the two pieces. We're going to notice right here, these two pieces are easier because they're broken, but this is at x, 1, 2. So this is at x is equal to 5. So let's start with our first piece right here. We have a closed circle. So this does include x equals 5. We have an arrow, so we know it goes on forever into the negative infinity direction. Again, this is a straight line, of course it's straight. It's also horizontal. So when we have a horizontal line, this is going to be y equal to 4. Y is going to equal 4 when x is less than or equal to 5. Let's look at our next piece here. So we have an open circle, so we're not including 5 in our domain, but we do have an arrow, so it goes on and on forever. So I'm going to pick 2 points here. Let me zoom in. Because I'm going to need to find my slope of this line. So I know my slope, see, I'm going to rise 2, go over 1, so my slope is going to be 2 over 1. Now what I said before is that sometimes we have to pretend that the piece has no constraints so that we're able to find the equation for that line. I need to find my y-intercept. To find my y-intercept, I'm going to need to interpolate here. It goes off the graph a bit. But my y, if this line kept going on and on, it would cross the y-axis right here. So this is negative 1, 2, 3, 4, 5, 6, 7. This is negative 8. And I need that for my line. I'm going to erase this because we know it doesn't go on. But now that I have my slope and my y-intercept, sorry, a little shaky there, I can go back and I know that y is equal to 2x minus 8 when x is greater than 5. Now I can put this together to write my piecewise function. So f of x is going to equal, it's going to equal 4 when x is less than or equal to 5, and it's going to equal 2x minus 8 when x is greater than 5. We're also going to need to evaluate functions. So if I were to graph number 8, f of x is equal to 1 when x is less than 4. So what I'm going to do, this is where my piece is going to change. So this is x equals 4 right here. I can also write f of x equals to 1. We can also call this y is equal to 1. So when x, it's not when it's equal to 4, but when it's less than 4, I have this piece right here. When x is greater than or equal to 4, we have the equation f of x is equal to 1/2 x minus 3, which we can also write as y equals 1/2 x minus 3. That means my slope is 1/2 and my y-intercept is negative 3. Now you will notice that negative 3 is outside of the domain of this piece of the function right here. But what we're going to do is I'm going to start at negative 3, go up 1 over 2, up 1 over 2. This is where we're going to start. Where I made that mark at 4, this is where we're going to start. So I can actually now erase these two lines. And it is when it's greater than or equal to 4, so I can keep going here. And now that I have some points, I can get my straight edge. And I'm going to go on forever because it's everything greater than or equal to 4. Now that I have graphed my piecewise function, it's asking me to evaluate f of 6. Evaluating f of 6, we know that this is when x is equal to 6. So x is equal to 6 right here. And my function lands right on 0. So f of x is going to equal 0. I've turned the page to number 9. We can also evaluate functions without a graph. We can use the written function to do so. The only difference is when I evaluate f of negative 2, right here, I know that x is going to equal negative 2. So we need to figure out which domain or where this x falls into. So we have when x is less than or equal to 0, the function is 1/2 to the x power. When x is greater than 0, the function is negative 2x plus 3. Well, negative 2 is indeed less than 0, so we're going to use this function here. So f of 2 is going to equal 1/2 to the negative second power. This is my x right here. 1/2 to the negative second power is 4. For b, we have f of 6. This is when x is equal to 6. This time, since 6 is, I'm going to use my arrows, come all the way around here. 6 is greater than 0, so we're going to use this piece of the function. This is going to equal negative 2 times 6 plus 3, which is going to be negative 9. I'll let you try C on your own. Have a great day.